This video is meant to give you just a bit more on implicit differentiation. We'll do one more example where we find the equation of a tangent line using implicit differentiation. And then we'll talk about whether explicit differentiation and implicit differentiation are consistent with one another. In this first example, we want to find the equation of the tangent line. So the equation of the tangent line to the curve x squared plus xy plus y squared equals 3. And we want to find it at the point 1, 1. So let's go ahead and take the derivative implicitly. The first term, if we take the derivative of that, it's just 2x plus, if we take this derivative of the second term, we're going to have to apply the product rule. So I take the first part times the derivative of the second part, and so that's going to be 1 dy over dx plus y times the derivative of x is just 1, and we don't need anything after that because it's an x term, plus the derivative of y squared, which is 2y dy over dx. And again, we have to add the dy over dx because this is a y term. And that's equal to the derivative of 3, which is just 0. Don't forget to take the derivative of this term. Some people forget, and then it leads them down the wrong path. So now we're going to gather up all of the terms that have dy over dx, and we'll take the other terms to the other side. So I have x dy over dx plus 2y dy over dx. I'm going to leave those on the left side. And then on the other side, we're going to have negative 2x and then minus y. Now I factor dy over dx out of these two terms, and I get x plus 2y, and that's equal to negative 2x minus y. And then I divide both sides by x plus 2y, and I get minus 2x minus y over x plus 2y. So that's my derivative. Again, this represents the slope of the tangent line, and we want to find the equation of the tangent line. And all we need to do to find the equation of a line is to have a slope and a point. And this is the point they gave us, 1, 1. Now, if they had only given us the x value of 1, we would have needed to find the y value. And in order to find the y value, we would have had to plug the x value in here to find the y value. But they gave us both, so that's handy. And so now all we need to do is to take that point 1, 1, and we plug x equals 1 in right here and y equals 1 here to find the actual slope at that point. So dy over dx equals negative 2 times 1 minus 1 all over 1 plus 2 times 1. It just happens that both x and y are 1, so that's convenient. And then we solve. So 2 minus 1, or negative 2 minus 1 is negative 3 over 1 plus 2 is 3, so the slope is negative 1. And then all we need is the slope and the point, and what we do is we say y equals, the slope is negative 1 times x plus b, and we can plug in when x is 1, y is 1. So I plug in 1 for x, and I know y is going to be 1, and so now I can solve for b. And so add 1 to, I have 1 equals negative 1 plus b. I'm going to add 1 to both sides, so I get b equals 2. And then that means that the equation of the line is y equals negative 1x, or negative x plus 2. That is the equation of the tangent line to this curve at the point 1, 1. So the last thing I want to discuss is whether implicit differentiation is consistent with explicit differentiation. And what I mean by explicit differentiation is if it's consistent with all of the rules that we've learned so far in terms of taking the derivative. We never called it explicit differentiation until now when we introduced implicit differentiation. But we want to see if they come up with the same answers. If you're able to take the derivative implicitly and explicitly, if we get the same answers doing so both ways. So let's look at an example. Suppose we had the equation y squared equals x squared plus 4. If we were to want to take the derivative of that explicitly, we would need to solve for y in terms of x. And so we would need to take the square root of both sides, and remember it's the plus or minus the square root of x squared plus 4. And if we just wanted the top half of this, if this parabola, we would take the positive root, so it would just be the square root of x plus 4. And if we wanted the bottom part of it, we would take the negative side. But let's go ahead and just consider the top part. If we took the derivative of this the traditional way that we've been taking the derivative, we would rewrite this as y equals x squared plus 4 to the 1/2 power, and we would have to apply the chain rule. So we would have dy over dx equals 1/2 times x squared plus 4 to the negative 1/2 power, and then with the chain rule times 2x. And so that would give us, when we simplified, the 2's would cancel, and so it would give us x over the square root of x squared plus 4. And that's our dy over dx. All right, let's try this implicitly and see if we get the same answer. And so if I wanted to take the derivative of this implicitly, we would take the derivative of the left side and we would get 2y. And remember, it's a y term, so we would need dy over dx equals 2x. That's the derivative of the x squared term. And then the derivative of 4 is just 0. So now when we solve for dy over dx, what do we get? We get 2x over 2y. And that's equal to x over y. And you may be looking at this and saying, wait a minute, it didn't give us the same answer. Here we have dy over dx is equal to x over the square root of x squared plus 4. And here we have dy over dx is equal to x over y. That doesn't look the same, does it? Well, if we look here, though, at what y equals the square root of x plus 4. And if we plug that in for y down here, what we're going to get is dy over dx is equal to x over the square root of x squared plus 4. And you can see that this is the same as this. So what does this mean? It means that taking the derivative implicitly is consistent with or gives us the same answer as if we were to take the derivative explicitly.